Okay, for section 2.5, I'm going to look at 3 problems for you today. Going to look at finding the rational zeros of any particular function that you are given. We're going to take a look at a problem that tends to give everyone issues, is writing a polynomial equation when you're given a specific number of roots. And then we're going to use Descartes' rule of signs to determine the number of possible positive zeros and the number of possible negative zeros for any particular function. Alright, so let's start with the first one. Let's find all rational zeros of the function 2x to the fourth minus 15x to the third plus 23x squared plus 15x minus 25. Alright, so I know they want me to actually find all the zeros and their rational zeros, so do you remember the rational zeros theorem where you take factors of the back number, divide it by all factors of the front number. So I'm taking plus or minus the factors of 25, so 1, 5, and 25, thankfully not that many, divided by factors of 2, which would be 1 and 2. So if I was making my list of possible rational zeros, I would have 1 divided by 1, 5 divided by 1, 25 divided by 1, so 1, 5, and 25. And then I would also have 1 divided by 2, I would have 5 divided by 2, and I would have 25 divided by 2. And if the problem said find the list of possible rational zeros, this is your list of possible rational zeros. Those are the numbers that when I start to do my synthetic division and I'm going to guess and check, those are the numbers that I want to try and start with. If it's not one of these numbers, then either they're not rational zeros or I've done something wrong. So I'm going to use synthetic division to help me do this, and I'm going to make sure I account for all the coefficients. It goes from 4 to 3 to 2 to 1 to a constant. So I have everything sitting there. So I'm going to use 2, negative 15, 23, 15, and negative 25. Now, realistically, when you're doing this for homework, it could be any one of these. I'm always going to suggest that you try one of the whole numbers first or one of the integers first. I can't guarantee that they're going to work, but I'm almost positive that it works for all the homework. Same thing on the test. Yeah, that's probably not the strategy you should do, is try all the nice numbers first. But I can tell you that one of those nice numbers should work. I'm not saying that those won't, but one of these nice numbers should work. So realistically, you have positive 1, negative 1, positive 5, negative 5, positive 25, negative 25 to guess and check with. So it's only 6. Saying that still takes a little bit of time. So no rhyme or reason, I'm going to go ahead and pick one of those numbers, and I'm going to try 1 and run through and do the synthetic division, hoping that this is a 0. Alright, so I drop down the 2, multiply to get 2, add to get negative 13, multiply to get negative 13, add to get 10, multiply to get 10, add to get 25, multiply to get 25, add to get 0, and I got lucky. It happened to be the first number I tried. That's probably not going to happen all the time. Hopefully it does, but that probably won't happen. That means remember this number. This is one of your x-intercepts, or zeros. Alright, I can look at this thing and I can see that there are definitely 4 of them, so I still have some work to go here, or some work to do. Remember, your goal in synthetic division is you want to get this equation down to a quadratic, because then you can use the quadratic formula, or you can possibly factor it. So I'm going to use the new numbers. Remember, this represents 2x to the third minus 13x squared plus 10x plus 25, and I'm going to do synthetic division with those. And pay attention to the back number and the front number. If for some reason they changed, they didn't for us, but say that became a 10, well, 25 is not a factor of 10. I could eliminate 20, or I could eliminate 25. That didn't happen for us, but you never know. Sometimes that will happen, and that'll trim the list down for you. Now, my suggestion is, if 1 worked, it's possible that it's a double root or a multiplicity 2. Try it again. Can't guarantee that it's going to work, but that's the first thing I would do. Otherwise, you're going to try a negative 1 and all the rest of them and get frustrated and realize, oh, wait a minute, it was actually 1 that worked twice. Alright, so go ahead and drop down the 2. Multiply, add to get negative 11, multiply to get negative 11, negative 1, and I can quickly see that there's no way that that's going to be 0, so it's not 1 again. So I move on to the next one. 2, negative 13, 10, 25. And overall, I just want you to understand what the idea is. The idea is you sit and you crank through all these numbers until you finally get this to be 0. Now I'm going to show you a way to shortcut, kind of use a shortcut for this on the homework. Probably won't be able to do this on the test. Maybe you will, maybe you won't, I haven't decided yet. But you can easily graph the function. So I'm just going to graph this original function. So remember, go to y is equal to 2x to the 4th minus 15x to the 3rd plus 23x squared plus 15x minus 25. Hit enter, graph it, and I'm just going to look at it. And by looking at the graph, I can probably tell what the x-intercepts actually are. So if you look at that graph, okay, yeah, it made sense that I picked 1. That definitely works. It looks like -1 probably works, and it looks like 5 actually probably works too. And then that one looks like it's in between. That one looks like it's somewhere in between 2 and 3. Probably that right there. Now I said the idea here is not to just plug this in and then look at it and say, oh, yep, I know what they are. The idea is I need to know that I'm using synthetic division to do it. What this calculator is going to help me do is it's going to speed this process up of guessing and checking. Because I can see it doesn't bounce off of 1, I would have known not to check this again. So now I'm going to say, well, I know -1 works. It saves me a little time from the guessing and checking. Let's plug it in and make sure that it does. Of course, knowing that it works means if it doesn't, then you know you've got an error somewhere. So I run through and do my multiply, add, multiply, add, multiply, add, and sure enough, I get it to work. So now I've got my second x-intercept. And then the whole goal of doing this is, remember we said we want a quadratic. This represented something to the 4th power. This is now to the 3rd, which is this one. And now that I've gotten through the synthetic division, that means that this represents something that's quadratic. So this is actually representing 2x squared minus 15x plus 25. And why is that the goal? Because we know how to solve that. I can figure out very quickly that I can factor or use the quadratic formula, and I'm going to have my answers. Now, if you want to try to factor, you multiply the front and back numbers together and you get 50, and you can't come up with this number, somewhat quick, that's fine. You don't have to do the factoring. So maybe you use the quadratic formula to find the other two. So I'm going to have 15 plus or minus the square root of 15 squared, which is 225, minus 4 times 2, or a, times c, or 25, all over 2a, or 4. And if you see the factors, by all means, go ahead and factor it. It's a good skill to be able to see the factors. Like I said, it may take you a little longer than it needs to do this, so it might actually be quicker to do the quadratic formula. It's kind of up to you. So it depends on how comfortable you are working with some of the bigger numbers that you have. So it looks like I have 50 times 4, or that's 200. So this is eventually going to give me 25 over 4. And so I'm looking at 15 plus or minus 5 over 4. So I have 20 over 4, and I also have 10 over 4. So when I list off my x-intercepts, I'm going to say that I have 1 from the first synthetic division, -1 from the second synthetic division. Looks like that's 5 and 5 halves. And these are my rational zeros. Important that you understand that your goal is to get down to a quadratic, because if these things were imaginary zeros or irrational zeros, something like, let's say 15 plus or minus the square root of 3 over 4, you're not going to find that guessing and checking doing synthetic division. The only way you're going to get it is to get it down to a quadratic. Alright, so that's the first example. Again, use a calculator just to guide you through the homework, but understand the main concept. Next example is writing a polynomial equation with the following zeros. And I can see that they gave me 4 of them. So eventually my equation should be something with an x to the 4th in it. Alright, these two, the integers, those are usually not a problem. When you put them in parentheses, it's always x minus the number. So those two, no big deal. I don't want to put those in parentheses like this. It's not that I can't, but there's something easier. Remember we talked about the sum and the product of the roots? Anytime you're dealing with a quadratic, meaning 2 x-intercepts, which is what I have right here, it's always going to be x squared minus the sum times x plus the product. And it's very important that I understand that, and this only works again when you're putting 2 together. Let's say I FOILed this out from these two. Technically I could use this if I wanted to. Well, FOILing that out or multiplying that out, I'm going to get x squared minus 2x plus 1x, so minus 1x minus 2. Well, say I use this instead. What do you get if you add 2 and negative 1 together? You get 1. So you'd have x squared minus 1x, which is what I have. What do you get when you multiply them together? Negative 2, which is what I have. So it actually works for anything, but we don't tend to use it for these because it's easy enough to just multiply those out. This one's a little more complicated. Anytime you have imaginary zeros or complex zeros like that, it's a good idea to use this thing. It'll be a little bit easier. So I'm going to run through and just add them together and multiply them together. That's supposed to be a minus. So let's think about it. Okay, if I multiply 2 of them together, it's going to give me x squared, right? If I multiply 2 zeros together, I should have a quadratic. The sum, well, I get lucky. The imaginary parts, or the radical parts, cancel. The sum is just 6, so it's minus 6x. Now the product, well, they are conjugates of each other, so multiplying this together is going to be actually a little bit easier than you think. Multiply these two together, I get 9. Insides and outsides are going to cancel. Multiplying the last together, I get minus I squared times 2. I squared I know is negative 1, so it's actually 9 plus 2, or 11. And that is the quadratic where those two zeros, or these two zeros would give you that quadratic. If you use the quadratic formula on this, you would easily get those two zeros, and that's a way you could check it. Alright, so I put the two quote-unquote nice x-intercepts together, or the integers together to get this one. Put the more complicated ones, the imaginary zeros or the complex zeros, together to get this one using this formula. Make sure that this is something that you know. It makes it a lot easier. And now I'm just going to multiply all this stuff together. So I'm going to take x squared and distribute to all three of these. And doing that would give me x to the 4th. It would give me negative 6x to the 3rd. Pay attention to signs. It would give me a positive 11x squared. Now distribute a negative x to all three of those. That gives me negative x to the 3rd. Notice how I'm staggering it, keeping the x to the 3rds on top of each other. Going to give me a positive 6x squared, again keeping the x squareds on top of one another. And then a negative 11x. It just makes it easier when you add. You could just add right down the columns this way. Distribute negative 2. It gives me negative 2x squared plus 12x minus 22. And now I just simply add down the columns. I'm going to get x to the 4th. Makes sense because I had 4 x-intercepts. Minus 7x to the 3rd. Adding these together, it looks like it gives me 15x to the 2nd. Positive 1x and minus 22. And there is a polynomial equation where if you went through and did all this synthetic division, you would be able to get 2 to work, negative 1 to work, and then that eventually would be the other one. So if you actually wanted to check to see if this was right and you had time, say 5 minutes to kill on your test, but you weren't confident in this, you could actually run through synthetic division with these numbers. Try it with 2 first, try it with negative 1 next, get it down to a quadratic like we did here, and then if you do the quadratic formula, it would eventually give you those two. So you probably are not going to have that kind of time, but if you do have time and you want to check it, that would be a way to do it. Alright, last problem for this particular section is using Descartes' rule of signs to determine the number of possible positive zeros and possible number of negative zeros. It doesn't tell me for sure that I have 2 positive zeros, it tells me that I could have 2. So to find the number of possible positive zeros, you are going to take the function, the original function, make sure that it is in order. So it's to the 7th. There is no to the 6th term. I don't need to add one in. I just assume that it stays the same sign. But make sure everything's in order. If for some reason these two terms were switched, then you need to put them back where the to the 5th term is first. And all you're going to do is you're going to go from left to right and count the number of times that you see the plus or minus sign change, or the number of times that the sign changes. So it starts out positive, stays positive, switches to negative. There's one sign switch. Stays negative, switches to positive. There's a second sign switch. It's now positive, stay positive, switches to negative. There's the third sign change. So the number of possible positive zeros would be 3, or if you go back and read the definition, it's that number and then less than a even integer. In other words, you basically take this number and subtract 2 until you get down to 0 or 1. So the number of possible positive zeros is 3 or 1. If for some reason you counted the sign changes and you got 7, you would say it's 7, 5, 3, 1. You just keep subtracting. If for some reason you did this and you got 6, it would be 6, 4, 2, 0. 1 and 0 would always be the last two numbers. Alright, so there's the number of possible positive zeros. Now to find the possible negative zeros, remember this is the number of them, not actually, it's not saying that 3 or 1 is a 0, it's saying that I possibly have 3 positive zeros or I have 1 positive 0. Alright, to find the number of negative zeros or the number of possible negative zeros, you have to not take h of x, you have to find h of negative x and then do the same thing, count the number of times the sign changes. Well, if you plug a negative number in any of these terms that have an odd exponent, it's going to make, so for example, let's say I look at this. Let's say that this is actually negative 1 instead of negative x. If I take negative 1 to the third power, it's going to give me negative 1 times negative 11 makes that positive 11. What's basically happening, it switches all of their signs. So all of these odd exponents, all of their signs in front of them are going to switch. All the even ones will stay exactly the same. So this term, because it's an odd exponent, would actually be negative 16x to the 7th. Odd exponent would become negative 2x to the 5th. Even exponent, so it stays negative 3x to the 4th. Odd exponent would switch it to positive 11x to the 3rd, I guess that is. Even exponent, so it stays x squared. Odd exponent, so it switches to negative 7x. And then this is just a constant and that can't change. Hopefully that makes sense. Again, if that's something that's giving you trouble, let me know and I can kind of walk you through that again. And now I do the exact same thing. I'm going to count the number of times I see the sign switch. Now it starts out negative and that's fine. Doesn't matter what it starts out as. And just work your way to the right. Stays negative, switches to positive. There's 1. Stays positive, switches to negative. There's 2. Stays negative. So I have 2 or 0 possible negative zeros. Right, that is your homework help for section 2.5. Having any questions or trouble understanding, please let me know.